Hi, welcome everybody. I'd like to welcome Andreas Dangle to Google. I've known Andreas for quite a while now. He's quite known in the world of document analysis and recognition. He is currently on the management board of DFKI, which is the German Center for Artificial Intelligence. He's also a professor of computer science at the University of Kaiserslautern in Germany. And even though I know his work mostly on document analysis, today he's going to talk about something totally different, which is a line of research he's been involved in for the past couple of years. He'll talk about the Semantic Desktop as an intimate supplement to memory. Welcome, Andreas.
That's it. So, thanks a lot, Luke. So I'm happy to be here today, and I'm also happy to introduce you to one of our main guiding teams in DFKI. But first of all, I would like to ask, who knows DFKI? Who don't know? Okay, so just the question. Just maybe some sentences. I have no slides with me. DFKI is actually the largest AI institute in the world. We have about 490 employees which work on various topics on AI. And we are a non-profit private research company, so to say. I'm a professor of informatics or computer science. All the directors have the same position. And the DFKI works with no basic money. Everything is acquired. So we are steadily growing, and our mission is to provide transfer on one hand side, but also to have leading edge technology on the other. And due to this, we already founded about 49 spin-off companies with about 1,200 jobs outside of DFKI. We brought out about 50 staff members to professor positions, etc. That's it. If you like to know more, please visit our webpage. So when I start today, I would first talk a little bit about what is the Semantic Desktop from our point of view and how to build it. Because as you know, Semantic Web is now one of the guiding phrases everywhere, but the problem is how can we get or how can we enhance the web to a more semantic level? And the question also, because of my background, is what could we do to also integrate information from paper documents of any kind in such a scenario? And furthermore, what can we make or how can we profit from user observation? So first of all, I'd like to talk a bit about what is a semantic desktop, and I just took a definition we put in one of our papers, and I just would like to read it in advance, and later on I'm going to explain this. So a semantic desktop is a device in which an individual stores all her digital information, like documents, multimedia, or messages. These are integrated as semantic web resources. Each is identified by a uniform resource identifier, URI, and all data is accessible and queryable as RDF graphs. Resources from the web can be stored and authored, content can be shared with others. Ontologies allows the user to express personal mental models and form the semantic glue, interconnecting information and systems. More than that, applications respect this and store, read, and communicate via ontologies and semantic web protocols. So the semantic desktop is an enlarged supplement of users' memory. This is our interpretation of this. And our starting point to think about is how the developments in the web are going on. And this is just a visualization of the 100 most important blogs in Germany. And it's just one way to show how much information is in it, how much is it accessed, and how the different connections are in between. If you consider this is some outcome of the recent trends everywhere, where it's a primary means of the information society that we put all the information together, mainly on the web, so everything we have can be found on the web today. So scientists publish their papers, and the salesperson put their catalogs of new products in the web, and the journalists have their news available. So most important in this is, however, that documents are mainly understood by natural language, so people are aware of what's going on. We have lots of mining technology, but in many cases we cannot ask why. We can ask when, we can ask how many, we can ask who sometimes, but why is the main question. So 80% of information today with respect to many studies is captured in unstructured technology, and it's very hard to make this available by technology to provide decision platforms and to further direct our processes. So today, researchers attempt to transform the web of links into the web of meaning, in which documents are described by a vocabulary, by a shared vocabulary of people, providing then the way how a machine can understand and can derive meaning from this vocabulary. But if you could see the semantic web, which is going on today, then it's still an initiative towards standardization, which means that people try to provide higher order languages like all, so the web ontology language, in order to have a framework to describe vocabularies. But the main problem is that people are not ready to manually create all this kind of vocabulary, and furthermore to maintain the vocabulary. So we need something that allows us to provide such a vocabulary by semi-automatic means. So the question is, how could we provide such a vocabulary to build ontologies, which is a kind of shared vocabulary for the society? If we try to find the right vocabulary at the starting point, there are already some very important questions to solve. What are the right terms to be used? If I show you these 4 fruits over here, and I want to ask you, what are the categories to put them in? What would your answers be?
Brown.
Which one?
Brown.
Brown? Oh, strange. However, any other proposal? The more red ones, the more green ones?
Colorful.
The one which?
Colorful.
The colorful ones, the one with a stick, the one without, the one with a more rough skin, the clad, or a more fine skin, the one I like, the one I don't like. So there are many ways to categorize. And this is just a simple example to show you. And we daily have to work on documents, and it strongly depends on our understanding of the contents of the document, on the situation we are, of the awareness of terminology we are using, in order how we do interpret contents of documents. And documents are mostly resources, and they strongly depend, however, who we are, what is our interest, what is our role, what is our recent time to work with the documents. So it's very hard to really provide categories in this sense. So coming back to some of my statements, to develop a kind of semantic web will be very hard because subjectivity is inherent in our thinking about contents. And therefore, we have to resolve the problem. So respective usability of a vocabulary strongly depends on the users, how the users categorize information. And there's only few support today in companies to categorize information by objective means. So if you just look at a study which comes out from Delphi Group in June 2004, you can see that with respect to 400 companies where they ask people how they categorize information, you can see that most of the people still do it by themselves. There are, of course, some companies which provide taxonomies, how people can categorize or are allowed to, or they can search for documents. However, with respect to our experience, people do not really accept such taxonomies because they do not reflect their terminology nor their specific interests. So we have to find other ways because the user tends to prefer its own way to categorize information. And I'll give you an example. Or first of all, I like to make some of a thesis that is that the bondage of formal organization of information inhibits creativity and limits the options of self-organization. On the other hand, a document is like a note. Today, we should not consider a piece of paper still or only as a document. Today, it's a note in a dynamic environment. This is constantly changing over time. So a document is something which is fluid, yeah, and strongly depends on changes in standards, in law, in references, or whatever. So we have to just resolve the traditional way how to archive documents, because it strongly depends how documents are used in specific informations by specific roles of people, etc. Coming to categories. Categories mostly are addressed by specific terms. These terms are selected in order to describe the main or common features of entities within such a category or class. And I would like to follow a statement by Immanuel Kant, maybe you know him, who said that imaginations without terms are blind and terms without imaginations are empty. So, which would say that if I have something in mind, I could tell you, you are not able to see. And on the other hand, if I would use a term you don't know, you have no image in mind. People today, they think about in pictures, imaginations, associations in their mind, and unfortunately, we have to do abstractions via the language. So of course, if I would use a concept you are familiar with, I'm sure, talking about my daughter, you know what a daughter is, but you don't know whether it's a small kid or a young lady, know how she looks like. So this is strongly driven by shared context and by the mental models in our brain, which are related to the beliefs, the values we have, to the experience, so on and so on. So communication always takes place in a shared context, coming from subjects, and this is very important also to how people could be creative. But we can also have a transfer of this idea towards our own laptop or PC, whatever we work with, that at our PC we are storing information of documents or single documents according to our own preferences. So our subjective view to the contents. So we define folders and we give the folder names, providing a kind of taxonomy, which is a conceptualization of the world, how we look to the world. But however, these concepts have no unique meaning, which means that I just take a simple example like this folder and give him the name vocation. We could have something in mind, collecting information about our preferences, what kind of vocations we do. But if I just use the term and tell it to somebody else, there could be a completely different meaning of vocations. And this is the reason why if employees quit, leave a company, there is a kind of loss of information, a symmetry of data, which is back. Nobody has time nor the experience to really explore. So if my colleague is on vacation, I would look at his or her laptop and look for information. It's very hard to find by just using desktop search. Yeah, you have to understand more behind that. And there's another problem with respect to these taxonomies. This is given that these taxonomies allow perspective considerations today. So for example, if I would take some of my talks today, the one of today or any others, and you might be interested and may be interested also to store it on your laptop, you always have the same problem. Where to store this talk? Where to store the slides? Because on an abstract layer, information has different dimensions. This is a who, a what, a where, a when, a why dimension. And it's always hard to put this information in one folder only, because the situation later on requires to have another perspective to the information. So the question is where to store the information. Moreover, there is a third problem that today we have no integrative view to information. We have the file system on one hand side, where we have these folders, we have our email folders on the other, and we have bookmarks, we have our archive system, another one, and whatever. So in here, there are collections of information which have, of course, in my mind, a lot of to do with each other. For example, that there are talks inside here, which I discussed with people over there, maybe taking place in a hotel somewhere in the world. Yeah? But these are unfortunately completely separated. And it's very hard to provide associations among this information. So in a first step, we took advantage of machine learning techniques, allowing to learn how people store information on the desktop, and furthermore, also provide multi-perspective access to information, while we use an integrative view to all of these sources. And this looks like that we allow a usual interface to information, but we have virtual views to information at the same time. One of these views can be integrated via the Explorer or via any system, while the other ones are just virtually, and they provide a where, when, who, why view to information, so that one document can be virtually stored in different folders belonging, for example, to the document type. Unfortunately, this is in German. The document type, for example, project proposal, addressing partners like Accenture or BMBF, having the organization of quality insurance, the department inside topics of AI, etc. So a document may be stored to different folders. And this works like that because we learn the contents of each folder, the document could provide a kind of electronic mental model. This is a kind of network of term-correlated concepts, yeah, providing a profile for all of the folders at the same time. So I'll show you some examples later. If we receive, for example, emails, the system can make proposals to what topics or what document types the system may be classified. So you can see this at the question markers here. It's just association the system gives you back. And the best thing is because it's the same mental layer I do have, I well understand the behavior of the system. So it's a very personal assistant right now in order to handle information. And then I can accept these proposals, for example, just making the hook at each folder. Otherwise, it's not relating to the profile of the folder. But as soon as I do that, so the electronic mental model, so to say, of a folder is adapted to the new document at the same time. Yeah. There are various retrieval technologies also included. I don't want to go into detail. We have a kind of feedback search and concept search and fuzzy search, etc. I have other slides of this technology. But just to sum up, this is, at the first step, it's nothing than a machine learning approach towards multi-perspective, integrated handling or associative handling of information. However, to summarize, there are a couple of advantages in this approach. That is that the contents, the text of information objects, whether it's a taxonomy, a folder, or a single document, they could all be related in the same way. The communication between a user and this kind of personal information or personal memory is driven by these conceptualizations, allowing to associate and to imagine in his or her own mental world. And furthermore, the combination with the perspective directions, user can have very nice possibilities to retrieve information. However, this is just a way to qualitatively or just to relate information to each other. It's not yet semantics. And the question would be, how can we profit from this in order to provide something of a higher level, considering these resources on a semantic layer without lots of manual impact? And I'll give you an example to that. If you transfer this idea I just presented to you to a real application environment, say an insurance company, where lots of clerks work on specific topics, and incoming documents then can be filed in different views at the same time, for example, document types, contact views, events, and so on. The system may give proposals in which folders such information may be classified, and the user may accept. And as soon as the user do this, I just have enlarged some of these folders, the user can activate some of the generic relations which are stored behind the folders, yeah, and they express some semantics between the folders. For example, that if the document is put in this folder, it is a notification of a claim. Or if it's in the folder of Mr. Smith, it's generated by Mr. Smith. Furthermore, it describes an accident. It furthermore addresses the car damage, and so on. And I could also have generic relations between folders of individual views. For example, if a document is stored in two folders of different views at the same time, we could further generate a link that this person here declares the event, or that this event implies a specific case. So step by step, just by classifying information, we on the fly generate semantic links in between. So we have further documents coming in. This is a certificate which generated by another person, addresses the same case, and comments on an accident. So if we have this, step by step we can collect information on a certain semantic layer. And so we consider each information as a kind of semantic web resource, whether it's a document of any kind, and also the constituents of it, like a message, the sender, the recipient, an address, or even a calendar event. And all the resources are identified by URIs, whether they are in the file system or in Outlook or wherever. And as a result, we can generate something like a personal information model. We call it PIMO. And to give you an example, we have this announcement, for example, where I have to give a talk very soon of the CASEM 2007, and we have this URI. And if we have an RDFS class, we can say that this is an event. Yeah. But furthermore, this also has a certain location, which also has another URI. Yeah. And this location here is an organization. And this conference is hosted by another organization. Yeah. And this also is chaired by somebody who has their own web page. And there's a speaker, namely me, who has another web page, and both of these are persons. Yeah? And furthermore, we can say that this person works for the university in Melbourne, while I do work for DFKI. And DFKI, again, is another organization. I further could combine native applications, namely Outlook, for example, where the address is stored of such a person. And I also could use calendar events. And all of those could be easily combined. So we could, while using accessing documents, handling documents of any kind, we can step by step establish a higher level representation of what we do. So we have networks of triples which assist us to file, organize, and share information of any kind. And this is called PIMO, as I told you. It captures all relevant information items at the same time, whether we have instances as RDF or we have concepts in terms of ontologies like RDFS. And the user then may access shared categories which are defined here, for example, like the most general one is the thing, and we could have persons and events and groups, organizations, whatever. And we could generate instances on the fly when we handle documents at the same time. We should take care, there's a concept called smushing, not to duplicate resources at the same time. And this is a kind of just mining towards having the same resources and avoiding to do that. I give you a link on that. You can read where to find it. I also, maybe you noticed, there are always papers. You can have a look in more deep or more detailed information about this. So we take the data here from native resources of various applications. We have Aperture SF.NET to provide an adapter to RDFF. And we have a kind of rebirth engine which then matches this to the existing ontologies, where we do the update of the PIMO model and have a certain user interface. I will talk about the user interface a bit later. So this is the current way how to do it. And so this is also the basis for the so-called Semantic Desktop, which is a kind of adaptive personal assistant towards the handling of information and allows a lot of different functionalities. I'll talk about this later. But most important, it combines the PIMO also with an important fact with user observation. So why do we need user observation? Because the user acts on specific tasks in specific contexts. And this is also a very valuable thing, how to assist the Semantic Desktop in how to help the user in the best way. So how can we profit from that? The first one is very obvious, that if we have a PIMO, and this is a kind of hierarchical organized ontology, we could just look at contents of simple emails, and the system could just make some proposals to what topics the emails belong. Yeah? And we also see that ontology is a topic, and that reviews is, that reviews are belonging to a conference called WMO something, and this is a conference, and we have knowledge management. This is a department at DFKI. So we can see this. But more than that, we could also, if we write a document, we can do a save as, and if we do a save as, the Dropbox opens up and makes proposals where to store the document best and how to relate the contents of the document to the existing PIMO. But a step further is, for example, that we are observing users when they browse in information. So there's an example of a web page with specific contents, and now we allow for information push for the user. What he's doing, whether it's a browser or whether it's an email application, don't care. So we have developed a kind of sidebar. It's an assistance bar to the user, which is adaptive in the sense that if the mouse is here or the cursor is in this application, the mini quire adapts itself and shows, for example, first of all, it allows full text search, but it also shows all existing tasks, all data sources, all concepts which are available. It also shows all current tasks which exist. It comes up with all content-related informations, with the categories, which the persons, and also the projects, which are always related to the contents of the actual application. Yeah? As soon as we change the application, going out of the browser to the email system, where we just open maybe a call for a conference, the mini quire adapts itself to the new contents, always showing the recent and the related topics of it. And furthermore, we also see, or we are able to then just confirm semantic links, which are proposed also by the system to be added to this consideration. So we combine traditional IR technologies with some rules which are integrated into this scenario, like such as with extract the contents of an invitation email and infer the location and attendees of the meeting. Very simple. This could be part of the PIMO. We also, this is a very recent one, it's not yet fully developed, but this is a kind of semantic tagging. If user consider contents of documents, we use web services, tagging services from the web in order to combine them with our PIMO and then make proposals to the user how the user can tag information. Another example is semantic search. So which means because we have the PIMO model with all the semantics, the concepts and the instances, we can input some strings in our semantic search entity, and the system then shows us relevant aspects to that, namely persons, projects, concepts, and events which are related to this string. So for example, the string VITO belongs, it could be the first name of a known person which is stored under this URI. There's another person found. How does it come from? Because, well, we also find a project. This is this project called Business Register Interoperability throughout Europe. And the guy who is the project leader is Bertin Klein, and Vito Guanella, he is a project member on that. So all related aspects are found by such a semantic search, which looks in more detail like that we have search fields over here. We have, first of all, the overview of the most important instances and basic classes. What we have another more detailed interview where we could provide rule-based retrieval of related instances, namely concepts and documents. There are other ones like customer requirements. So it's not limited to this consideration depending on all the classes you're using in the PIMO. But for example, we have Sparkle rules behind that if you found a project, also show the members. You can retrieve them with respect to the query itself. So our architecture for this semantic desktop has twofold. The one which is below combines the native sources from Outlook, file system, or email server with Apache crawlers. And then we have a kernel of Sesame 2 repository with the PIMO store, resource store, and a couple else. And then a couple of services, including clustering, tagging, crawler, and so on. And we have some interfaces which are provided through the web itself. Namely, we have an editor, we have a personal wiki, a semantic wiki, application plugins, and desktop applications. Just to give you examples, we have already realized a interface towards Firefox, Thunderbird, or Outlook, even to Enquire 2, where we have such plugins, and it's very easy to browse and to search via these plugins in the PIMO for related aspects you need. However, if we consider resources themselves, they are of course valuable for individual users. But it's also important to note that most of the information is captured, as I told at the beginning, within documents. And the question would be, if we already know about persons, events, topics, etc., which are described within documents, how could we further deepen the analysis into the documents themselves? And we just started to use lots of our experiences in document analysis to do that. And the first one is for knowledge workers which are not working on mass applications of document analysis problems. For example, at their personal desktop. When I talk about future of office work, we also have to think about interfaces which allow us to bridge the gap to Gutenberg's world. And so we work with a kind of table camera. I just presented this at the ICTA conference in Curitiba last week. I have it with me in the car, unfortunately, but I can give a demo, however. So we have a camera, and we staff the camera with OCR and the PIMO itself. And the camera allows then, or it projects, first of all, a kind of laser frame on the desktop. You could put in a paper over here. You may click, and you get the paper in your laptop with OCR information of it. And then the PIMO itself proposes a kind of category for the document, and furthermore, identifies in the text known concepts, known instances, known persons, known events. And this is then published within a semantic wiki, which is shared by our group, for example, where all the known items like DFKI, this is a known institution, BIS is a known project, Kaiserslautern, the city I came from, is known by the system, etc., my person. So it's very easy also to use the PIMO to do a kind of intrinsic tagging of document, not only the extrinsic view, just to tell that this is a kind of invoice or whatever, but also to look into the contents and to build relationships on the semantic layer. And this is a very important aspect, because when working with document, with respect to your specific problems, your individual project, it's also important to look more into the text. Another way to do it, like we see it, is to use pen and e-paper. We just started a new project. We're using the Anato pen, which is stuffed by, all of this, not only ink, but a pressure sensor, so we can really do online recognition of handwriting and gestures and so on, but we also tend towards a kind of semantic gesture making on the document. As soon as we find a new person which is unknown up to this moment, we could just do brackets in a certain way to show the system that this is a new person. Yeah. So we are building different interfaces to integrate printed information, paper-based information into our considerations. Another very important topic is I talked about user observation, and up to now I showed you only the example of this browser where we have mouse position and cursor maybe to use as context information, but there is much more we can do. And last year we started a very promising approach about eye tracking, which is eye tracking is traditionally used in advertisement to just check how people look on specific information to do optimal position of the advertisement information you want to give to it. But today the technology in eye tracking allows us, without any special device, just to look at information and be very accurate. And this is an example from in-house, from Google, how people look at information provided by Google. Just 10 results. And our intention is to also observe the user while she or he reads information on the screen. Yeah. So, for example, if we have a document on the screen, we are now able to just track the saccades over the text, the duration of fixation, and therefore could also determine reading modes, whether the text is carefully read, or a user is skimming over the text, or is neglecting specific passages of the text. This is very important. Assume just you would put in a document in a folder, but you only read the second paragraph. Why should you index the whole document? You would not remember the whole document. You should index, of course, but you should individualize the way of indexing, because the user will remind this was the important thing for him. Yeah? So this is one of the most important outcomes of our research, that we just published a paper at CHI, that we now are able to really measure the relevance in the way user reads information. Yeah? And this is another way of visual feedback to information, which is valuable for the future. We also integrate this into our semantic wiki considerations to keep track of attention and information in the personal workspace, etc. And so to sum up, I have some more ideas about it, but let me first sum up to now. So we also think that, I mentioned it at the beginning, that the web is changing several considerations towards the web of people, and the focus today is set on taxonomies, on community building, collective intelligence, and most important, this also affects the way how people work in the office. And so the sharing and collaboration mode is changing step by step, opening itself, yeah, giving information. It's more important now to know how instead of collecting information. Hunters and collectors are out. Yeah, sharing information is in. So the semantic desktop we see is one of the driving paradigms in order to provide a new way of desktop computing, where we use on one hand side RDFS, RDF, maybe old sometimes, but integrating also native applications which we have in our workspace. So the web is part of our thinking and part of our workspace. On the other hand, the documents we generate are becoming part of the web. And we have trusted networks of friends which allow people to work on other people's information. And this is also part of our strategy, that semantic desktops are very nice on one hand side, but you have to consider the recent trends, what's going on in the whole web. So we are going to socialize the semantic desktop, which means that if you consider the web 1.0, And we see the semantic foundation, this is still very low, and also the community relationships, but we today have Web 2.0, and we also build on a semantic web. And our intention is that we can both combine both via the semantic desktop, having trusted communities which build PIMOs, and then we have a kind of ontology mapping and merging in between with established knowledge goods. No, tradable knowledge, which is handleable by machines, which describe limited domains of expertise and which could be shared among different peers. So we applied in 2005 in the EU for a project called Social Semantic Desktop. The project name is Nepomuk. This is the largest integrated project right now from the last call in the EU, with a lot of partners. And the best thing is, up to now, we have not only this 15 fixed project partners, but we were able to acquire 50 other partners, including big companies like Hitachi, which share our ideas, and this is open source. The platform we provide up to 2008 is open source, so everybody can share and develop new technologies for the social semantic desktop. So this is the kind of plan we have, because our intention is also to provide a couple of spin-off next years on the social semantic desktop. So we start with internal exploitation, and we also would like to come to external exploitation in the year 2009 and 10, etc. While we already today have some companies we convinced to use it internally. So furthermore, we also think about how to provide a physical environment for the semantic desktop. And I just convinced a couple of sponsors and companies to provide us money, and this is the first scheme drawing of it. It will be available very soon, mid of October already. So we are going to integrate all this technology, having 3 large screens around us and having various interface technologies like tablet PCs, touch screens, pens, table cameras I told you about. And in January 1st, we also start with e-paper. We have some very valuable partner on that, and see what happens. So thanks to my team. So it's a big team, as you can see. And thank you for the attention. And if there are questions, I'm, of course, ready to answer. Thanks. Please. Please, I can answer.
It was really neat to see the work that you've done. I think that given a rich semantic network, you've shown that a lot of your tools have really cool applications. My question is, in your experience working with the tools that you've written, how feasible or easy is it to get the user to develop a really rich network of semantic information?
Okay. I have to repeat the question. The question was, up to my experience, how the user is willing to participate in developing such a scenario at his own desktop and use native applications and put them together and build ontologies. Well, to tell the truth, we made ambivalent experiences. It strongly depends on the kind of work a user is doing. We already tried to convince, for example, insurance companies in a kind of scenario I just mentioned. But the truth is that today their technology and the way to think in their technology is far away from ours already. So they have very basic infrastructures. Some companies share 4 different archives. So there is a heterogeneous platform, which is very hard for them to handle. The complexity is very high. But if you go in environments like we are working in, and we have tools which are not only manual driven, but rather learn from the user step by step, adapting the behavior towards the user, people are very willing to do that. All of my group members, without any pressure, use these tools. Yeah, and we have shared ontologies already finished. And so it's a lot of fun to work on such platforms. And this is something I think this is inherent to the Web 2.0. Those people who participate in YouTube and Flickr and share the information, yeah, they are also willing, if there are tools available, yeah, which support them in building up, first of all, trusted communities. So small webs. So bring the web from the desktop to small semantic webs, and then evolutionarily establish the web of meaning. This is the strategy we build on. Please.
My mailboxes are organized in linear order right now. What if I will apply PIMO? And what kind of organization for my mailboxes?
Yes. The question was that mailboxes are sometimes organized in a linear order, so they're most very flat. And people do it in different way, temporally organized, topically organized, contact organized. So it's really very individual how people do that. So what we did, and I showed you this multi-perspective way to organize information. It allows you in the first step to just import some of your taxonomies, for example, from the file system, and then start to work. Which means if you have folders and you put some, whatever you have, say contacts, you put everything to contact, it learns about how you consider information if it belongs to contact. But we also recognize that over time, people tend towards opening up a different view because they recognize that it's inconsistent just to have one single view. So they put out, for example, I had an example where the documents are organized by the root named documents, nothing else. And then there are documents, for example, of an employee of a company called German Post, so German Postal Services. But German Postal Services is not a document. But in the folder, again, there were other documents like an offer. So people recognized that this user recognized it and opened up another view, like organizations, and put this folder. It's very easy, drag and drop, pull the folder here, and also make a link to other folders. And over time, it's also possible that the system could be reconfigured in the way that you ask the system to reclassify the information in order to the new profile, which is generated over time. So the answer is people learn how to use the system and step by step provide alternative views to it. Please.
You mentioned that most of your group use the system. So I would suspect that the users in your group are mostly sophisticated users. Is there a usability lab experience with unsophisticated users?
The question was that the suspect is the suspect to my statement that most of my group members are sophisticated users, and whether we have experience of unsophisticated users using, for example, usability cases or tests with them. Okay, so in a very early stage with some of our technology, including this personal memory technology, we did some usabilities with a mixed kind of success, to tell you the truth, because you need some kind of knowledge how to use such systems in order to profit. Yeah, this is very important to say. With respect to the Semantic Desktop, we changed a little bit the strategy in that way that we would like to have a technology which acts in the background. You don't see it really. Yeah. But you are able to complement the technology by the plugins. You just browse or link or search, which I showed you in native applications. So the intention is to not change anything, but rather to have additional functionality working in the background. But however, the plan is that in the third phase of these Nepomuk projects, we are concentrating specifically on usability. And we have usability groups in Nepomuk which today already design use cases for it to get some feedback from users. Please.
Given the relevance of the information is dependent on so many different things, the context, the timing, and the person, and so on. So
why even bother have an ontology? Why not just, when you're doing search, just filter these things based on attributes?
Yes. The question was because of the very heterogeneous way how people organize the information, why using taxonomies and not just search, correct? Well, search, from my point of view, only addresses intrinsic characteristics of information, which means that you need to have the string inside of a document. But sometimes documents have a certain meaning, like being an invoice without having the term invoice in it. So you need also extrinsic features to describe the information. And furthermore, you have to develop a kind of objective taxonomy, which is common for all persons at the same time. Many companies do that. And you can see this also in the developments of Google. Google also returned to folders. The question is why? People tend to organize information within folders, to have a complementary way how to use it. It's very important. Search is important. I completely agree. But sometimes document should be searched by information which is not captured in documents, but in human way of thinking. Please.
I know that efficient RDF stores are kind of an unsolved problem. I was wondering how much data your tools are generating if you're running performance issues.
Yeah, the question is that with respect to RDF, RDFS, and the performance, the scalability of the system, up to our experience, how many data we generate when we work with such environments. Well, today in our group, the people have PIMOs which are about up to 500 nodes, I would say. 500 different concepts to be used. And this is still somehow handleable. You should not, I'm not sure how this would develop. It's, what we can identify is that many colleagues use existing concepts of others when they already exist, because the system proposes concepts which are pre-given by others, so they do not reintroduce something similar. So over the time, I think there is a kind of a logarithmic way how to step by step find a kind of threshold which would help, but I can't tell you real results up to now.
I see. Do you know like how many triples are in a typical Sesame store?
Yes, we have up to 7,200 triples at one workspace. Yeah, but maybe you've heard about this new initiative in Germany about the Theseus project. DFKI is the main research partner in that, and Theseus is a very huge project right now. You can see that in all the news tickers in Germany. It's a project for 5 years, and it's an annual budget of close to 50 million euro. And our intention is to really give a push to semantic search. But there are also two tendencies. There is one who is more top-down, which is more top-down, and mine is more the evolutionary bottom-up approach. Okay, that's it. So thanks a lot for coming.